Greetings and welcome to this installment of Introductory Solid Modeling using SolidWorks. And this project is called the Hinge Block. And it features an interesting variety of modeling techniques, but I'm particularly interested in the function of a hinge. Now, a hinge, of course, is to rotate, and I believe this one rotates about this axis that we're staring down. So these two circles are coaxial. The holes are coaxial, and even more interesting, they lie on the same plane. Those axes lie on the same plane as the axes for these two holes. So we develop a specific plane in the block to create that. Now also there is a scoop cut out to allow space for whatever part goes in here, and it's between this face here and this face here. So we create a new plane in there to help cut that out. And there's a similar cutout here, a little bit different geometry, but important nonetheless. We also have a small boss here. So we'll show a few different techniques and tricks. So let's start. Let's create a new part, and this hinge block is defined all in millimeters. So we'll want to go right down here and change to millimeter gram second. Then we're going to start with the main overall outline. Now I could use this front plane, top plane, and right plane to go through those circles, those holes, at least one of those two planes, or maybe make it off of the one face that of the scoop. But because this part has zero symmetry, I'm going to use the lower left corner of the main boss, the main extrusion, to define our origin. So I'm going to sketch off that front plane, and starting here, I'm just going to make the broad outlines of the part itself. I don't care that much that we are accurate, having exact lengths yet, because we will change those in a little bit. So just making these lines. Notice I'm waiting for that horizontal line to show up here, and come back to the origin. Now this is close to the shape, but it's not exactly the shape. And that's where our dimensioning comes in. Now I can dimension, for example, this line. Just by clicking on it, it's going to assume that I want the length of that line. In this case, it's true. But another way I could do it is by clicking on this horizontal line and that horizontal line, giving me a vertical dimension. It's mostly the same, depends on what I may delete later or what I truly intend. Do I really want maybe this face to be 10 millimeters, or do I want the distance from this face to that face to be 10 millimeters? Sometimes it's important, sometimes it's not. I'll show you an example in a little bit of when it can be important to make that distinction. So this time we just want the 10 millimeters. We have an overall width. Notice that I don't have a specific line that is going to define our overall width, so I have to go from vertical line to vertical line, and 64 millimeters there. Now this 19 millimeters, I could go from point here to point here, but if I click it wrong, the wrong spot, it's going to give me an angled length, which is not what I want. And if I click here, I'll still be making it a horizontal distance, but it'll think that I'm asking it to go from point to point, when what I believe I really intend here is that this point here is 19 millimeters off of the end. So I want to make sure that's a horizontal dimension by clicking at least one vertical member. Same thing over here. I want this to be 6 millimeters. I want it to be a horizontal dimension. So I'm going to click at least one vertical member. Now to make the angle, click here and I click here, and I could click here to make the 45 as shown, but if I wanted to, or if it was defined differently, I could go here, or I could go on this side. It does make somewhat of a difference, but I usually prefer to go with the smaller angle, and that's what's on our drawing in any case. So now we want to do the overall vertical dimension, which is 38, and that's the vertical dimension, so I will want to make sure I click at least one horizontal component. And I have one more angle here. And then we just need to know where this is. So if you got to this point and you were not quite sure why this is still blue, you could just grab it and move it and realize, oh, we have a horizontal issue. Maybe it's a dimension, maybe it's a relation. But that's pretty easy to fix. And we have a 25 millimeter dimension there. Alright, now our entire drawing has turned black, which means that the sketch is fully defined. It means the computer knows where every single point is and no more. I don't have to tell it that this line is 39 millimeters from this line, because it does the math. 64 minus 25 is 39. If I did put a dimension like that in there, it would tell me, hey, you're over defining this. Do you want this to be a reference dimension? Do you want it to be the defining or driving dimension? So that's what happens. That's why things might turn yellow or red at times. Well, I am all set to protrude this boss. Now I don't want it coming out this direction. That's what this shows. I want it to go the other direction. And the overall dimension there is 78 millimeters. Now also note that I could have simply made a block here and then cut away, but I wanted to use good techniques to define a good protrusion or revolve or something like that first, and capture some design intent in our very first feature, whereas a block doesn't capture a lot of design intent. And so here is our initial feature. Now I'm going to make the boss that comes out from here. It's very simple. I'm going to make an extruded boss base, and this says to select a plane or find an existing sketch, but we don't have an existing sketch. I want to extrude this off of this plane and reorient it to show that. Okay, I'm going to change this view so it's normal to the sketch, and all I need to do is make a rectangle starting here, going up here. Now notice I specifically clicked on the lower right corner, went up to the upper left. If I clicked on the lower left corner, it's fine. If I go to the upper right, there's nothing for me to click on that I can align to. So then I will have to separately click here, hold the control key down, click on this other edge that I want it to align to. So I've got the control key down, I'm going to click there. There we go. Now I can click on both of them, and I want to make them collinear. So that's why sometimes it's advantageous to actually sketch off something so it's easier to pick. But I made them collinear, and that's what this symbol is all about. And it turns this black because it knows exactly where it is. The only thing left is to figure out where this is supposed to be. And we have a dimension that shows that. So going from there down to the bottom, 16 millimeters. And I am done sketching that. So I hit exit sketch. Wants to know how far out I want to send this, and the drawing shows it's 11 millimeters deep, and that works. Okay, the next step is to go do the scoop. For the scoop, we're going to create a plane that is offset from the front face here. So I went to reference geometry plane, and my first reference is going to be this face. And just need to fill in this form area. And the distance shown is 9 millimeters. Make sure that's the direction we want. If we wanted it on the other side, we could click that, but it's exactly where we want it. It says it's fully defined, and there is our plane. Now from this plane, we're going to sketch our cut. So we want to make an extruded cut, so we're going to click here, and it's going to ask us to sketch. Since we already had the plane selected, it assumes that we want to make a sketch. If we'd already had the sketch made, we could have maybe used that sketch for the cut. But right now it's asking us to make a sketch. And this one is fairly easy. We're going to actually use, instead of a line, we're going to convert some entities. We're going to take this entity here, and we're going to use it, and this entity here, and use it, and this entity here. You may ask, well, why are you using those entities? We just need to cut and make the geometry of the cut. Well, sometimes the computer has a problem when you don't close the loop. So I always recommend closing the loop. Well, another trick we can use is that if you, instead of clicking on and making lines, you want to make a line and then a curve, you can click, make that line, then come back out, and it will make a curve for you, like this. I will do it again so you can see what I'm talking about. I'm going to click here, then click here and make our line. I'm going to go out like this, then come back here, and then it's going to make an arc for us. And to get out of drawing, I simply hit escape. This center needs to be 10 millimeters off from this edge. So put that dimension in, tap in 10, and we have that. Next, this radius here needs to be 41 millimeters. And it's pushing everything way too far. So we need to know where this edge is supposed to actually come up to. There we go. I can just click and drag it. And we found a height on the drawing from here to this flat of 25 millimeters. Aha! And now everything turns black. Now if you'll notice, this point is hanging way out over here. I personally don't like having loose ends, and the computer sometimes has a problem with it as well. So what happens when you have a relation that you want to get rid of? All you need to do is left click on that relation so it turns blue. Notice how it's associated with that line there, and use your delete key on your keyboard, or you can right click and delete it. But now if you'll notice, this point turned blue, so not quite sure where the point is. It has this curve pretty well defined, that's why it's black. I'm going to take this point and drag it down here, and even recognizes that I want it to be coincident, so it creates that right there. Now, our convert entities seem to not work, so we're going to try it again. Must not have hit the green check mark. That's a common mistake. Aha, there they are. There, here, and here are the entities that we're looking for. And notice how we need to close the loop. This would cause a problem if we kept this open. So I'm going to click here, hold the control key down, click down here, and I want these points to merge. It does not like the points to be merged. Probably because it knows that this point needs to be part of this. So I'm going to delete that relation. Now this point can be merged. I can just drag it down to that point and it will be all set. One last point of openness is right here, and we'll just need to either use the convert entities, which we can do, or draw a regular line. I'm going to use the convert entities so I can show you something else. Here's my edge 1, and now I'm going to use the trim entities function, and this power trim is great. consider it like a razor blade or a knife, and you click, hold, and drag. See the light gray line? And as it crosses an entity, it will get rid of that entity. So you're just literally cutting it out, and all that's left is what you wanted. So now I have an entire loop mostly aligned to existing geometry. We've got 3 different dimensions here, and we're going to cut this in this direction. So I was done with the sketching, so I will exit the sketch, and now it assumes the correct direction that I wanted, not that direction but that direction, and the distance given is 60.033 on the high side and 60.22 on the low side. I'm going to assume that the nominal is 60 1/4. May have been right, may not have. That depends on the designer. And I'm going to model it with the nominal dimension. And there is our scoop. Click on it, double click, and you should see all the dimensions. Notice how the sketch dimensions are in black and the feature dimension is in blue. Okay, for the cutout on the other side, we're going to do an extruded cut, and we're going to select this face. And we're going to do very similar procedure. Let's start with changing my orientation so I'm facing it directly. Click here. Come out here, and then back, and then come up to make Now notice that this automatically creates a tangent relation between this arc and that line, which is just fine because that's what we're looking for. Instead of using the convert entities, I'm just going to keep clicking and making lines. And I came around to finish up my loop, and I'm good with that. Now, this center is supposed to be on this edge. So I'm going to click here, hold the control key down, click on that edge, and I want that point to be coincident on that edge. 2 more dimensions that are key is the radius of this. Now, if you look at the drawing, it looks that the center is 10 millimeters from this face, but that's not true. The center of the R41 is 10 millimeters from the face, but not the R16. Notice that there's no connection through them. So, last but not least, let's try to drag this back and put in the other dimension that will define the horizontal. And that's where that other 10 millimeter dimension comes off the edge. Okay, now it's all defined in black. So looking at it from the perspective of the drawing, we've got that 10 millimeter distance and the 16 millimeter radius. And of course I made an entire loop, made sure I had all my references right, and I am good to go. Obviously I don't want it that deep. It indicates simply a 2 millimeter depth. And that's what I'm looking for. Okay. Now we've got our cuts and our bosses all taken care of. Next step is placing the holes in. The first thing I want to do before I quite get there is I'm going to make a new plane. So I go to Reference Geometry and Plane, and I want that plane to be 14 millimeters off this surface, and that's not the direction I wanted. So I need to click on this to flip it, and I'm going to go to 14 millimeters. Aha! That looks a lot better. It says it's fully defined, looks right. Good. Now I'm going to make two extruded cuts, one here and one here, that are going to go through just their respective sides. So I'm going to make an extruded cut, and I'm going to sketch it on this face, and then I'm going to click normal to that face, and here I have my plane all ready to go. And it's just a circle, so I can dimension this, and it's a nominal 14.3. in diameter, and I have a height from the base here of 29 millimeters. And it's all turned black. The computer knows exactly where it is. 29 from the bottom. It knows it's 14 off from the side because I drew it and aligned the center to this plane. And it knows its diameter. It's all you need for the circle. Now the question is, how deep do I want it? I could go blind and just tell it to go somewhere through there, and that'll be fine, but that doesn't really capture my design intent. What I really want it to do is just go through this section. So I can choose that. So I can go up to surface. Which surface do I want it to go to? That surface. There it is. And so no matter how thick or how long this scoop is or how short it is, this cut will only go up to that surface that I picked. Now we're going to create another one just like it right here. So let's make an extruded cut. So I clicked on that plane originally, so when I click on extruded cut, it goes straight to sketching. And I just need to make a circle here with the correct diameter. And diameter looks to be about 11.1 millimeters. And then instead of giving it a vertical dimension like we did the other one, simply click here, hold the control key down, click there, and these two are concentric. So it knows exactly where the center is, exactly what the diameter is, and therefore it's fully defined. Now I'm going to cut this. How far? Blind? No. We want it to go to the surface. Could have also done next or through all because it doesn't have anything going on there. Okay, two more features are left. The first one is going to be on this surface, and it is a 10mm diameter hole that goes all the way through, but it has a 14mm diameter counterbore that goes 8mm deep. So this sounds like a job for Hole Wizard. The other interesting thing is that part of it is going to be actually under here. So we're going to go, instead of ANSI inch, we're going to go to ANSI metric, and we're going to go to custom sizing. So our hole is 10mm through, and our counterbore is 14mm in diameter, and that is at a depth of 8mm. You should familiarize yourself with holes and the Hole Wizard, but there are a variety of different shapes and sizes that you can go through. It's a very powerful thing, but sometimes it can be a little tedious or difficult to work with. And don't think it is all that magic. We need to make sure we've got the positions right. Now, if you want to do holes on different faces that are at different locations, not all on the same plane, you'll need to use 3D Sketch. In this case, we're only making one hole. No need to click on 3D Sketch. If you don't hit 3D Sketch right off the bat and you needed it, you'll have to go back. So what this does right now is we are sketching points. So I'm going to select the face where I want to place the hole, and there's the face. And now we're in sketch mode, and I'm going to select a point right here. Now I could actually select a point right here. Problem is, it's not actually on the face. Sometimes that can cause problems when you're in 3D Sketch. In this case, not so much, because we're doing 2D. But you don't usually want to select it right on, say, an edge like that, if that's where you want it, because it has a hard time recognizing it. I usually select off the edge and then put my relations in later. If I wanted to do multiple of these, I could select other locations on that plane, but I only need one hole this time, so I'm going to hit escape and hit check mark, and there's my hole. Now I can go back in, or I should have done this before, and I'm going to right click on Sketch 8 and going to edit it, and all this is the point. Click on that point, hold the control key down, click on our plane, and make those coincident. Next, after hitting the green check mark, I'm going to make a dimension from this edge to this point, and it is 11mm from that edge. Now notice that the point has turned black, and we are all set in its location. But you say, uh-oh, we put it on that plane down there and not on the curve. So we have this material still above it. Well, the specification is for the plane, so we'll have to make another hole that comes up and out, and we can do that. If we go to Features, Extruded Cut, and we have a plane already pre-selected here. I'm going to exit out of that, and I'm going to select a different plane. So I'm going to go to Extruded Cut, and then I want to select this plane down here. And I'm going to convert entities, and I'm going to use this edge And since that edge is already predefined, it's all black already. And I'm good with exiting the sketch. And that's not the direction I want it to go. So I'm going to flip our direction, and now it's going to come up through the hole and through this material. And instead of making it blind, I want it to go through everything. And there we have our counterbore hole. For our final hole, I'm just going to put it right down here on this face and send it on up through. So I've got an extruded cut on this face. Let's make a circle. And I can take this point, hold the control key down, select that plane. I want the point to be coincident on the plane. Then dimension the diameter, 6 millimeters, and its distance from the center of the other is 30 millimeters. Problem is, I can't find the center of this. So what I want to do is I want to go to View and Temporary Axes, and that shows up right now. So temporary axes shows you axes of circular or semicircular or radius typed items that may not be helpful most of the time, but you might want to turn it on here and there. So now I can make my dimension from here to here. And this shows 30 millimeters. And there's that 30 millimeters, 6 millimeter diameter. And I'm happy with that sketch. And I'm going to tell it to go through all. Make sure it gets everything. And now we have completed Hinge Block. If you'll notice, we used a variety of cuts, a couple of planes, even used a hole wizard, and we were able to use a variety of other sketch techniques and types of cut techniques to make sure we got everything we needed. We also used these planes where they were important to find very specific either location planes, like for the axes of the holes, or for that matter a cutting plane for the scoop. And I hope this helps.